formulas down because these are on your pink sheet. So you have all these formulas. You can refer to your pink sheet. Like I said, the purpose of these formulas, it's going to allow us to find exact values of other angles that are not appearing on the unit circle. Just to recall or refresh your memory, again, we know 0 degrees is equivalent to 0 radians. And we know the sine of 0 is 0, cosine of 0 is 1, tangent of 0 is 0. At 30 degrees, what is 30 degrees equivalent to in radians? Remind me again. Pi over 6. And I know the sine of pi over 6 is a half. Cosine is square root 3 over 2. What's the tangent of pi over 6? Square root 3 over 3. .45 in radians is equivalent to what? Pi over 4. Sine and cosine are both the same, which is what? Square root 2 over 2. And then the tangent would have to be 1. 60 degrees is equivalent to pi over 3. So then the sine we know is square root 3 over 2. Cosine is a half. And the tangent would be square root 3. So just, you are going to have to remember all these unit circle values for the sections. That's why I want to make sure. So the way the sum and difference formulas works is this. You're going to determine two angle values whose sum or difference is the given angle. So what I mean by that is this. Look at question number 1. Find the exact value. And anytime it says exact value, you know it's not a calculator question. 75 degrees. The issue is 75 degrees is nowhere on the unit circle. So can you think of two of our angles from our unit circle, 30, 60, 45, or adding or subtracting those two angles together that would add up or subtracted would give you 75 degrees? 30 and 45. So you agree with me that 30 degrees plus 45 degrees equals 75 degrees. So that's what we mean by the sum and difference. So I know that 30 degrees plus 45 degrees equals 70 degrees. Again, there may be more than one correct combination of angles that you could add or subtract together. So again, for a given problem, there may be multiple combinations. So there may be another pair of angles from the unit circle that we could add or subtract together to give me 75 degrees. So there may be more than one correct formula that we could use for this. But we're all in agreement that 30 plus 45 is 75 degrees. So am I adding these two angles together or am I subtracting? Adding. So on your pink formula sheet, which column do you think you're going to look in? Are we going to look in the sum or the difference? Sum. Now I want to find the cosine of 75 degrees. So what I'm going to do is I'm going to look at the cosine sum formula. So my cosine sum formula, the cosine, I'm just copying this right from my pink sheet. The cosine of alpha plus beta is the cosine alpha, cosine beta, minus sine alpha, sine beta. Doesn't matter the order in which I add 30 and 45 together. Couldn't we say 45 plus 30 as well? Yeah. So remember, these sum formulas, again, you may have written down on your paper 30 plus 45. Your friend may have 45 plus 30, but they're both going to be correct. So now what you're going to do is we're going to use the appropriate sum or difference formula. So what you want to do is you're going to rewrite, again, I'm going to call 30 my alpha, 45 my beta. So now what I'm going to do in this formula is I'm going to substitute. I'm going to take out these symbols and I'm going to replace them with the two angles that I picked to add together. So the cosine of 75 degrees is going to be equal to the cosine of 30 degrees, the cosine of 45 degrees, minus the sine of 30 degrees times the sine of 45 degrees. So the idea now is notice that we have angles from the unit circle. So now from the unit circle, what is the cosine of 30? Square root 3 over 2. This is where I said you've got to revisit your long lost friend, the unit circle. What's the cosine of 45 degrees? Square root 2 over 2. Minus What's the sine of 30? 1/2 times the sine of 45 degrees, square root 2 over 2. So now all I did was I've taken the values from the unit circle. That's why I wanted to make sure you had some practice first thing when you came in about this unit circle. Now follow your order of operations. You're multiplying and you're subtracting fractions. What by PEMDAS are we going to do first? Multiply. So remember how you multiply fractions together. You just multiply the numerators and multiply the denominators together. What is square root 3 times square root 2? Square root 6 over 2 times 2, which is 4, minus 1 times square root 2 is just square root of 2 over 4. Well, at least I already have a common denominator, don't I? So I don't have to worry about getting a common denominator. Can I subtract square root of 6 minus square root of 2? No, remember, you can only add and subtract like radicals. The numbers underneath the radicals have to be the same. So my numerator has to stay as square root 6 minus square root 2 all over 4. So like I said, the purpose of the sum and difference, we took an angle that was not on the unit circle of 75 degrees, but now we can find the exact value for it. So it expands, it opens up the door to find the exact value of a lot of other angles that are not on the unit circle. That's the purpose of the sum and difference formulas. So any questions on that? All right, let's take a look at another one. And remember, once you evaluate your common trig values, remember, simplify with no radicals in the denominator. Remember, make sure you rationalize your denominators if you need to. Okay? All right, let's take a look at 17 pi over 12. So I only put on the board writing these angles with a denominator of 12 in the first quadrant. But I can expand this and go into the second quadrant. Look at 2 pi over 3. I want to find a pair of angles added or subtracted that gives me a denominator of 12, don't I? So let's look at 2 pi over 3. What is 2 pi over 3 going to look like with a denominator of 12? 8 pi over 12. 3 pi over 4 with a denominator of 12. What's it going to be? 9 pi over 12. And then I'll go down to 5 pi over 6. That'll give me a denominator of what? 10. So it's going to be 10 pi over 12. And I'll do pi with a denominator of 12. What's that going to look like? 12 pi over 12. Okay. If I had a different denominator, I could do the same thing for all these angles. Yeah. Remember, I want to pick a pair of angles that will add up to give me 17 pi over 12. So I've written a whole bunch of angles with a denominator of 12. Can you see a pair of angles that I could add or subtract together to give me 17 pi over 12? Yes, which pair do you see?
Pi and 5.
So pi and what else?
5 pi.
We waited to get to 17 pi over 12. So 2 pi over 3 and... So you agree with me that 8 pi over 12 plus 9 pi over 12 gives me 17 pi over 12?
Yes.
Does anybody else see another pair? I don't think I see another pair. So that's probably the best pair. Like I said, sometimes there may be another pair. All right? But everybody agrees with me that 9 pi over 12 plus 8 pi over 12 gives me 17 pi over 12. So everybody has an agreement with that statement, that 9 pi over 12 plus 8 pi over 12 is equivalent to 17 pi over 12. And we know that 9 pi over 12 is equivalent to 3 pi over 4. 8 pi over 12 we know is going to be 2 pi over 3. Okay? So I want to find the sign. So what do you think? Am I going to be on the sum or the difference column? Sum, because I'm adding together. So I'm going to use my sign of alpha plus beta. So the sign, and I'm just going to recopy this formula from my pink sheet, is sine alpha cosine beta plus cosine alpha sine beta. And again, I'm going to let alpha be my 3 pi over 4, beta be my 2 pi over 3. So I'm going to take alpha out of my formula and replace it with a 3 pi over 4. I'm going to take a beta out and replace it with a 2 pi over 3. So I've got the sine of 3 pi over 4 times the cosine of 2 pi over 3 plus the cosine of 3 pi over 4 times the sine of 2 pi over 3. Remember, I'm trying to find the sine of 17 pi over 12. And clearly 17 pi over 12 is not on the unit circle. So this is what we use these sum and difference formulas for. So what's the sine of 3 pi over 4? Now watch your signs, because you're no longer in quadrant 1. Some of these angles are in quadrant 2. Remember, don't forget, you're all students take calculus. These negative signs can eat you alive. Remember, if your angle's in quadrant 1, everything's positive in quadrant 1. Only sine and cosecant are positive in quadrant 2. What does the t stand for? What's positive down there in quadrant 3? Tangent and the cotangent. And then in quadrant 4, what's the only two positive? Cosine and the secant. All right, so watch your negatives when you're doing these formulas. So sine of 3 pi over 4 is what? Is it negative or positive? Positive. So it's going to be positive square root 2 over 2. Cosine of 2 pi over 3. So I'm in quadrant 2, so is cosine negative or positive? Negative. So what's the cosine of 2 pi over 3? Negative what? 1/2. Plus cosine of 3 pi over 4. 3 pi over 4 is in quadrant 2, so is that positive or negative? Negative what? Negative square root 2 over 2. And then the sine of 2 pi over 3 is going to be what? Positive.
Square root 3 over 3.
Very good. So be careful of the negatives, guys. You guys go ahead and finish that for me. Go ahead and multiply that. Okay? So I'm going to let 3 pi over 4 be my alpha, pi over 3 be my beta. So I have the tangent of 3 pi over 4. No, because you're adding. It would matter if I was subtracting. So tangent of 3 pi over 4 plus tangent of pi over 3, all divided by 1 minus the tangent of 3 pi over 4 times the tangent of pi over 3. Unfortunately, guys, the tangents are the trickiest because you have a fraction. Because I know you guys just absolutely love working with fractions oh so much. So now, what is the tangent of 3 pi over 4? Negative 1. Plus, what's the tangent of pi over 3? Square root 3. All over 1 minus, again, you just told me the tangent of 3 pi over 4 was a negative 1 times the square root 3. Is everybody good up to this point? Any questions? Great, my job's done. Because we're leaving the world of pre-calc. Guess where we're entering? The lovely world of algebra. And that's part of what you have to understand. Is it the trig? So if you're okay with what we did up to this point, you're good on the trig. You're good. Because the rest is now just going to be simplifying in algebra. We're entering that lovely magical world of algebra land. First of all, what's this minus and negative in the denominator going to give me? Positive. Is it okay to leave a radical in the denominator? No. So what are we going to have to do with this fraction? Multiply top and bottom by what? 1, the conjugate. Remember the conjugate. So I'm going to multiply top and bottom by the conjugate. What is the conjugate of 1 plus square root 3? 1 minus square root 3. That's the problem with the tangents. A lot of times you're going to have to end up doing that conjugate to get rid of the radical in the denominator. So you have to FOIL. Be careful when you FOIL. You have a negative 1 times 1. What's negative 1 times 1? Negative 1. Negative 1 times negative square root 3 is going to give me a what? Well, negative times a negative is a positive, so I have positive square root 3. Inner term, square root 3 times 1 is just a square root 3. square root 3 times negative square root 3. Negative 3. Combine like terms on the top. What's negative 1 minus 3? Negative 4. Square root 3 plus square root 3. How do we add radicals together? Remember how we add a square root of 3 plus square root of 3? Just 2 square root 3. Over. Now let's look at the bottom. Remember, you're doing conjugates. So do I have to FOIL? Remember the trick with conjugates? Do I have to FOIL? It's just the first and the last. So remember, what's 1 times 1? 1. Square root 3 times negative square root 3 is a... So negative square root 3 times 3 is a negative square root 9, and then the square root of 9 is 3. And then what's 1 minus 3? Negative 2. Am I done? I can simplify it, because what can I divide out? I can divide everything by a what? Negative 2. So my final answer then is going to be 2 minus square root 3. That's your final answer. So with the tangents, guys, a lot of times what happens is you have to do that extra algebra to get the radical out of the denominator. Okay? Danny, what? You ready? So like I said, if you were okay up to this step right here, you're okay on the trig. Anything past that had nothing to do with trig, it had to do with algebra. So that's where you have to decide what's giving you the most trouble. Is it the trig part, or is it the simplifying the algebra? And then we can come in and Broadlock and help. Yes, Tony?
So we divide them all by 2?
Negative 2, yeah.
By negative?
Yeah, because you had a negative 2 on the bottom. So this, as long as everything in the numerator can be divided by the 2, then you can divide it out.
So we put 2 minus.
Yeah.
So there's only 2.
Okay. Any other questions on that one? All right. So sometimes, ladies and gentlemen, you can simplify an expression by going in the opposite direction of the sum and difference formulas. So this is basically now going in reverse. So now we want to identify, is this coming from a sum or difference? So notice, look at this formula as being a cosine alpha, cosine beta, sine alpha, sine beta. So looking on your pink sheet, which one has a cosine alpha, cosine beta, plus sine alpha, sine beta? Is that coming from a cosine sum or a cosine difference formula? Cosine. Careful with the cosine formulas, because look. Cosine difference, exactly. So then alpha is my 170, beta is my 125. So this is coming from my cosine difference formula, so I have 170 minus 125. If you look here on the pink sheet, it's the cosine difference formula is a cosine alpha, cosine beta, but it has the plus sign in here, which is what you have right here. Yeah, so be careful with the cosine one. It's opposite with the cosine formulas. Again, you don't have to memorize these formulas. This sheet will be given to you. You just have to make sure you know how to work them. What is 170 minus 125? 45 degrees. And what is the cosine of 45? Square root 2 over 2. Look at number 5 and see if you can pick what formula number 5 is coming from. Negative 60. So then I have the sine of negative 60 degrees. So where is negative 60 degrees located on the unit circle? Quadrant 4. Is sine positive or negative down there? Negative. So it's going to be what? Negative what? 3 over 2. At least the tangents are pretty obvious. So we know that number 6 has to come from either the tangent sum or the tangent difference formula. So again, look at 80 degrees as your alpha, beta as your 55 degrees. So which one is it? Is it the tangent alpha or tangent beta?
Tangent sum.
Tangent sum. So tangent of 80 plus 55 degrees. And what is 80 plus 55? 135. What quadrant is tangent located? I mean, the 135. Second. So is tangent positive or negative in the second quadrant? Negative. So what is the tangent of 135? Negative 1. You guys go ahead and try number 7 on your own. So again, I know that it's coming from, if alpha is 40 and beta is 10 degrees, it's coming from the tangent of 40 degrees minus 10 degrees. So I'm trying to now figure out what is the tangent of 30. Square root 3 over 3. Exactly. Yes, Tony. Oh, I'm sorry. I'll get you one. No, because 30 degrees is at pi over 6.
Oh, okay,
Yeah. So any questions, guys, on the sum and difference? All right. So does everybody have